Hello there, I am Arvin Kenneth from AMT 2-6. For this video, I am going to discuss the functions of the three major parts of a DC generator: the field frame, the armature, and the commutators. So what are we waiting for? Let's get started. A DC generator or a direct current generator is an electrical machine whose main function is to convert mechanical energy into electricity. One of its major parts is the field frame. The field frame has two functions. It holds the windings needed to produce a magnetic field. It also acts as a mechanical support for the generator's other parts. The actual electromagnet conductor is wrapped around pieces of laminated metal called field poles. The field coils is made up of many insulated wire that fits over the iron core of the pole to which it is securely fastened. A DC current is fed to the field coils to produce an electromagnetic field. This current is typically obtained from an external source that provides voltage and current regulation for the generator system. Let's talk about armature. The two primary elements of armature assembly are the wire coils, also known as windings coiled around an iron core, and the commutator assembly. The armature windings are evenly spaced around the armature and mounted on a steel shaft. The armature rotates inside the magnetic field produced by the field coils. The core of the armature acts as an iron conductor in the magnetic field, and it is laminated to prevent the circulation of eddy currents. The other part of a DC generator is a commutator. It is located at the end of the armature and it consists of thin insulators and copper segments. The insulator is often made of mineral mica. The electrical contact is being formed because of the brushes riding on the surface of the commutator. Due to friction, it causes brushes to wear out. That is why carbon brushes are being used, for it is soft enough to prevent undue wear of the commutator. Aside from that, it is also hard, making the brush last longer. So that's it, guys. I hope that you have learned something about DC generators. I am Arvin Kenneth from AMT 2-6. See you guys again on my next video. Hey, what is up, guys? I'm Arvin Kenneth from AMT 2-6. Last time, we have discussed about the different parts of a DC generator. For this video, let's talk about the different parts of a battery. Let us start with the protective casing. It is the housing or cover of the battery to protect it from damage. Next is the positive and negative terminal. They are the terminals of battery or other voltage source towards which electrons flow through the external circuit. Another part of the battery is the cell divider. Its function is to keep the two electrons apart to prevent electrical short circuits, while also allowing the transport of ionic charge carriers that are needed to close the circuit during the passage of current in an electrochemical cell. Positive and negative electrode. The positive electrode in an electrolytic cell toward which negatively charged particles are attached. The anode has a positive charge because it is connected to the positively charged end of an external power supply, while the negative electrode in an electrolytic cell toward which positively charged particles are attracted. The cathode has a negative charge because it is connected to the negatively charged end of an external power supply. Dilute H2SO4, or also known as sulfuric acid. It is a mixture of sulfuric acid and water is used as an electrolyte in lead-acid battery, where it undergoes a reversible reaction where lead and lead dioxide are converted to lead to sulfate. Besides, it is used in batteries because sulfuric acid is a very important commodity chemical. That ends our video. I hope that you have learned something about the parts of a battery. I think that's it, guys. Keep safe. Again, I'm Arvin Kenneth from AMT 2-6. See you guys again on my next video. Hello guys, I'm Arvin Kenneth from AMT 2-6, and for today's video, let's talk about spark plug servicing. Spark plugs should be withdrawn at the intervals prescribed by the manufacturer for testing and maintenance. Since the rate of gap erosion varies with various operating conditions, engine types and the type of spark plug before the normal servicing period is reached, engine loss traceable to defective spark plugs may occur. Normally, only the damaged plugs are removed in such situations. Since spark plugs can be quickly destroyed, it is not possible to overemphasize the proper treatment of the used and new plugs during installation and removal of spark plugs from an engine. Spark plugs should still be separately treated to avoid damage, and fresh and reconditioned plugs should be kept in separate containers. The ignition harness lead must be detached before a spark plug can be removed. Loosen and detach the spark plug from the spark plug with the elbow coupling nut using the special spark plug coupling elbow wrench. Take sure to pull the lead straight out right in line with the plug barrel center line. Damage to the barrel insulator and to the ceramic lead terminal can occur if a side load is added. The neoprene collar can be attached to the shielding barrel if the lead cannot be quickly separated in this way. By pulling the collar, cut the neoprene collar loose as if it were a nut being unscrewed from a bolt. Identify the correct dip socket size for your spark plug removal after the lead has been disconnected. On the hinge handle, apply constant pressure with one hand, keeping the socket in place with the other hand. If the socket is not kept in proper alignment, the socket can tilt to one side and destroy the spark plug. Carbon and other combustion materials are dispersed around the spark plug and cylinder in process of engine operation, and some carbon may also reach the shell's lower threads. As a consequence, to break the spark plug loose, a high torque is usually required. This factor imposes a shearing load on the shell section of the plug. They should be placed into a spark plug tray after extracting the plugs. In spark plug reconditioning service, the first step should be a visual inspection. The thread should be inspected for damage or nicked threads on the shielding barrel and on the shell that screws into the cylinder. For corrosion, nicks, and cracks, inspect the lead shielding barrel. For insulator cracks, chips, and excessive electrode wear, the firing end should be inspected. If the spark plug fails a visual inspection, petroleum fluid can be used to degrease it. Keep the solvent out of the shielding barrel with caution. Never soak the plugs in solvent. Remove the lead compound deposits by means of a vibrator cleaner after drying the firing end of the plugs. By using an abrasive blaster, the firing end will now be cleaned. Typically, this is achieved with a cleaner tester for spark plugs. The plug can be rotated while the firing end is exposed to the abrasive blast, so all the region of the firing end is washed. To remove the abrasive stuff, the firing end experiences a comprehensive air blast after the abrasive blast. Shielding barrel insulators can be washed with a solvent-saturated cotton cloth or felt swab, wood alcohol, or some other permitted cleaner. Using a light and a magnification lens, the shooting end should be inspected. If the plug passes visual and cleaning tests on the firing end, then a circular thickness gauge can be used to set the spark gap. The spark plug can be tested using a tester through which a high voltage passes through the spark plug and fires the gap. The firing end of the plug is exposed to air pressure to measure the pressure in the chamber of the engine as this test takes place. The plug should be returned to its holder, ready for placement in the engine if the firing pattern is fine. I think that's it guys. I hope that you have learned something about spark plug servicing. See you guys again on my next video. Hello guys, I'm Arvin Kenneth from AMT 2-6, and for today's video, let's talk about Magneto Timing. The spark plug in a cylinder needs to start at a particular moment for an engine to run properly. To generate the energy needed at the required time for the spark, the engine may otherwise run rough or may not run at all. The two areas of timing a magneto are internal and external. A number of things must occur at the same time, or in a well-orchestrated sequence for the engine to function. Within the magneto, magnetic rotor must be just past neutral axis or E-gap. The points must be just opening, and the distribution rotor must be pointed at the correct cylinder. Within the engine, the intake and exhaust valve must be closed. The piston or cylinder that is to fire must be close to the top of its compression stroke. It must have a fresh air or fuel charge. The selected wires from the magneto distributor must be connected to this cylinder, and the crankshaft or magneto must be spinning. If all of these conditions are met, the cylinder will fire. Timing is initially set internally in the magneto. It is then set to the engine. Both setting procedures may call for initial growth settings, followed by some means for fine adjustment. Usually, the first thing to be set is the distributor rotor alignment. Depending on the magneto, the distributor will be indexed to the rotor shaft during initial assembly of the magneto upper and lower housing. This calls for correct alignment of the drive and driven gears. There are indicator marks for this alignment. Most can be set for either left counterclockwise or right clockwise hand rotation. The next step is to install the rotor points cam. On some, this can be indexed infinitely, and others it will be 1 or 2 positions depending on rotation. Then for most magnetos, set the rotor at the point's opening position or E-gap. Adjust the points just to open. Move rotor maximum opening to verify the point range of operation. If the points don't have the correct range of operation, even though they are in time, the coil will not charge correctly or the points will wear out prematurely. Once E-gap and range are with limits, auxiliary points may be adjusted. Adjustment of points will require the use of a feeler gauge, a screwdriver, and a degrees of rotation indicator. The points are secured with 2 screws where one attachment is slotted. By carefully moving the slotted end with the other screw snug, it can be set and secured. I think that's it, guys. I hope that you have learned something about magneto timing. See you guys again on my next video.